Hey guys, this is Miss Pascual, or you know me as Sensei. This is Mr. Alvarez. He will be helping us today. In this video, we will be covering the test review that will help you to review for your test on the 13th, this Thursday. It will be on radical functions, transformations of functions with rational exponents and inverses, and some application problems. Alright, let's begin.
But hold on! Before you actually get into this review, we're going to need a quick refresher on some things. She's going to be using Geometer Sketchpad to show you, okay?
Now, a big portion of the test is covering transformations of the parent function for the square root. I'm just going to review a little bit of the basics of transformations of the square root parent function. In this unit, we're using the square root function. And this is the equation for the parent square root function. Y equals the square root of x. And we know that the domain being all real numbers greater than or equal to 0. And same thing with the range. All real numbers greater than or equal to 0. Square root, it looks like an R.
Before the equation that we're going to be working with on the sketchpad is going to be in this basic format.
Where y is equal to a times the square root of the quantity x minus h plus k.
Don't be so put off by all the letters. A, h, and k are only going to be numbers, and each one is going to affect the parent function in some form. In the case of the parent functions, the corresponding number values will be 1 for a, h will be 0, and k will be 0. That leaves us with the parent function that you see written up here.
So in the square root function, we have three basic parameters, a, h, and k values. I'm going to increase the a value here. We already have it at the parent function. Let's just assume that it's at 1. Because
the sketchpad is wonky sometimes.
And it won't let me move it to 1. Well, anyway, this is the parent function for the square root. So let's see what happens when I increase the a value. It is the vertical stretch.
Stretchification.
It gets taller or shorter. And watch as I move the a value to be a negative. It flip-flop. Reflection across the x-axis. So that's what the a value does. It gets taller, shorter, or flips it over the x-axis.
At what points does it actually get shorter?
Between 0 and 1.
Even in the negative case?
Even in the negative case. Just take the absolute value. Now let's see what happens when I change the h value underneath my radical. It moves it from left to right. Now for the third and last parameter, our k value. Let's see what happens when we change the outside value. It moves the graph up and down. On your test review, the first page is basically they give you equations of all these different types of transform functions from the parent square root function. So what I went ahead and did was I went ahead and I graphed the parent function on each of these. So we can see what the newly transformed graph looks like in relation to the parent function. If you're not sure of what points to plot, you can use your graphing calculator. Just go to y equals. To plug in the square root of x, you just go to second and then press x squared. That should give you the square root. And then we put x in close parentheses. And when you graph it, you do have your R-shaped graph. To get more specific points, just go to second to graph and then your table values. And hey guys, notice if it's negatives, there's error. That's because we cannot take the square root of a negative number. Here are your points, 0, 0, 4, 2, 9, 3. And you can use those 3 points to form your curve. For number 2, we have y equals the square root of x plus 3 plus 5. We can see here that in place of a there is a 1, so there was no vertical stretch or vertical compression. So what we have here is plus 3 on the inside and then plus 5 on the outside. Insiders, this is the horizontal shift. Whatever number's on the inside, it'll tell me how much to shift left or right. But insiders, they lied to you. So instead of going to the right, positive 3, we really went to the left 3 units.
Your biggest hint is the fact that you see a minus h in the standard form, and in this particular transform graph, you see an opposite sign, plus 3.
Thus, insiders, they lied to you. So I would take this point right here and then shift it to the left 3 units. But I want to take into account that there is a plus 5 in place of plus k. That means, hey, outsiders, they don't lie. I actually went up 5 units. I'm going to take this as a reference point, move it to the left 3 units, and then up 5 units. So this is a really bad drawing, but I just shifted this point to the left 3 units and then up 5 units.
Because the graph has no vertical stretching or compression, even though you're sketching it on the test, just go ahead and make it the same shape if there is no stretching or compression, just to make it easier on yourselves. The only difference is just going to be the point that you're starting at.
Next, we need to find the domain and range. Domain, remember, is your x values, and range is your y values. So I'm going to set this up two ways, in interval notation and in inequality notation, so that you can be familiar with both formats. In the inequality notation, we use x is in between two things, and then for the range, we use y is in between two values. For my domain, it's my x values. So scanning the graph from left to right, smallest to largest, negatives to positives, I can see that it starts off at -3 and it's included, and it goes all the way to infinity and beyond. And it's not included because
Infinity is
a concept, not a number, therefore do not include it. Same thing for the range, except this time you scan from the bottom to the top. Your newly transformed graph starts off when y is -5, included, all the way to infinity. And don't let this graph throw you off. Just because it's not going up as quickly doesn't mean it's going to stop at some point here. Even though it's increasing at a very slow pace, it is still going to be increasing forever and ever and ever. And to write this in interval notation, we have -3 to infinity. Because this is included, I use brackets. Because this is not included, I use parentheses. -5 is included, and it goes all the way to infinity, not included.
both formats are perfectly valid.
We have y equals negative the square root of x minus 2 minus 3. In place of a, I have a -1. If it's a negative, what happens? It flips downward. So I can put that as my first transformation. Inside of my radical, I have x minus 2. Remember, insiders, they lied to you. It's a horizontal shift, so instead of going towards the negatives 2 units, I'm going towards the positives 2 units. So therefore, to the right 2 units.
You could even say, comparing the standard form to the transformation here, that they both have minus. So, if they have the same sign, it's all right.
And over here, in place of positive k, I have a -3. That means that is my vertical shift. I am going down 3 units. I'm going to use this 0, 0 as my reference point again. I'm going to take it to the right 2 units and then down 3 units. And it reflects across the horizontal, so flip-flop. I have an upside down R shape. Then for your domain, for your newly transformed graph, scan from left to right. On the left bound, it is at a 2, included, all the way to infinity. And in interval notation, it is from 2, included, all the way to infinity, not included. And now for your range. You started from the bottom, now you're here. It started, hey, it didn't really start anywhere. It's forever and ever going down, down, down. So it's from negative infinity, and it stops when y is your upper bound of a -3, and that is included in your range. So it goes from negative infinity to a -3 included.
So basically, if you ever put an equal to sign or a bracket next to an infinity symbol, you're fired.
And here's a little hint for your test, or in any case in math. If you have an equation and you're asked to graph it and you forgot all the different types of transformations, use your graphing calculator. You have y equal. Use your graphing calculator. All you need to do is just plug it in and it'll give you the graph. And there's your graph, which looks exactly like that. Here we have y equals -4 times the square root of x. And you might be wondering, hey, where's the h value? And hey, where's the k value? Let me rewrite it, so don't panic. It's actually there, not visible. Just x minus 0 plus 0. For the a value, we can see that it is a negative and it is a number greater than 1. That means it reflects across horizontal, and it got taller, vertically stretched. Now, in regards to graphing these ones, best thing to do, go to your graphing calculator if you want specifics on what points go where.
So to put this into the calculator, we just want to go -4, then second square to bring up the square root, x. And that's it.
And as you would expect, it did flip across the horizontal, and it did get taller. It vertically stretched by a factor of 4. So if you want to have more specific points to graph, go to second graph, And then there's your points. Just scroll throughout.
Like we said before, back on the left, the only thing that transforms about the graph is that it gets stretched and it gets flipped.
So because it only flipped across the x-axis in regards to the parent function and it's stretched, the domain, it's still the same. It all exists from 0 to infinity in regards to the x values. So our domain, it's still the same. However, for the range values or your y values, notice, because we flip-flopped it, my range will also be a flip-flop. So scanning from the bottom to the top for my new blue graph, it starts from negative infinity to when y is 0.
Okay, so for the next one, I'm kind of just going to break things down a little bit differently than Miss Pasquale does, just because it's a little bit more to my comfort. So what I'm going to do is write down the a, h, and k values. So a, as seen here, is simply 1/3. H, you don't see it there, so we interpret it as 0. And for k, it's -2, so -2. So now we can look at each of these and try to break down what the transformation for each of them is. So for the A transformation, because the number is greater than 0 but less than 1, the graph is actually going to be compressed by a factor of 1/3. Now for H, because our H is 0, comparing it with the parent function, there is no change. I'm just writing it here just to illustrate it. Now for K, because we had that -2, that the graph is going to shift down by 2. To graph the function, I'm going to plot our first point. So with h0 and k being -2, all I do is go down here. But I still need the rest of the graph to figure out how exactly I'm going to plot it. So again, in our y equals, I'm going to put in 1/3, then second square root once again, x, close parentheses, -2. Here we see the shape of the graph. It's a lot flatter compared to our parent function. So when you go to our second graph to figure out what points we can plot for it, you have 0, -2, and the points here are a little difficult to graph, so if all you're going to do is sketch it, in comparison with the parent function, just make it look a lot flatter. It almost looks like a straight line, it's so flat. But that's what it's supposed to look like. Onto our domain and range. Because there's no real change in h, the domain is going to be pretty much the same. So it'll be 0 less than equal to x less than reaching all the way to positive infinity. Because left to right, the leftmost x value is 0 and it extends for, well, forever. Interval form will look the same as our parent function. And now for our range, it's going to be much like we saw up here. So, even though it doesn't reach negative infinity as quickly, it's still going to get there. It's just going to take even longer. So, it'll be negative infinity less than... no! Just less than, no equal sign. If you do an equal sign, you'll fire yourself or something like that. So just less than y less than equal to our highest y value, in this case is -2. In interval form, it will be parenthesis, negative infinity, -2 bracket.
So for the last one on this page, we have y equals negative square root of x plus 4 plus 7. For your a value, it reflected across the horizontal because of that negative. Now for your h value inside, the radical insiders, they lied to you. So instead of going to the right 4 units, it's actually going to the left 4 units. Now for your k value or your vertical shift, which was a positive 7, it does not lie, it goes up 7 units. And again with your domain and range, this time x is in between negative 4 as your left bound, all the way to infinity. And for your range values, just like the one above, it starts off at negative infinity, not included, all the way to our upper bound, which is at 7, included.